That is calling functions. Now let's talk about function definitions. Defining a function is the term that we use to talk about kind of naming a function, taking some code and giving it a name, and also specifying inputs and outputs, as we'll see in a minute here. How do we do that? Well, I'm going to take this formal definition and break it down. So this is what I want you to know about functions, how I want you to think about functions. A function is a named block of code that can optionally take some input, perform some routine with that, and then can optionally return some output. I'll break that into kind of 4 pieces here. Named block of code, can take some input, perform some routine, can return some output. So starting with 1 and 2 here, named block of code that performs some routine, you'll notice these are the only mandatory ones. So 3 and 4, you can optionally take some input if you want. You can optionally return some output. So let's start with the simplest possible function. It's a function that is just a named block of code that performs some routine. This is what the syntax looks like for defining a function in its simplest possible form. We always have this keyword def, D-E-F, which by the way stands for define. So you can remember it that way. We're defining this function, def. That's the keyword. Then after a space, we have the name of the function. So def space, whatever name you want to name the function. This is your choice. This is the name that you'll later use to call this function, to call this routine. And then we have an open parenthesis and a closed parenthesis. We always have these parentheses here, followed by a colon. And then everything after that colon, all of the lines that are indented, define the body of that function, which is really what this routine is that we're going to perform. And I want to point out here, you might notice how similar this is to the syntax that we saw in while loops and for loops and conditionals. Whenever Python has some sort of body that needs to be defined, it's almost always specified by a colon followed by indented lines. And everything part of the body is everything that's indented. And as soon as we go back to de-indented lines, those lines are no longer part of the body of whatever construct that was that you were creating, in this case a function. Maybe this is a little clearer if we look at some actual code. So let's say you have this code here on the left that you just wrote, and you'll notice that this code will, for some particular number, it'll print out the absolute value. Because if the number is positive here, greater than or equal to 0, we print the number. If it's negative, we print the negative of that number. So here, num is not greater than or equal to 0, so we'll print negative num, which is negative 12, which is positive 12. So if we want to wrap this and encapsulate it into a function, go ahead over here on the right and create, using our def keyword, def space, then the name of our function, which I think a good name here would be absolute underscore value. These parentheses, a colon, and then all of the indented lines are part of the body. And over here I include us calling the function. So the name of the function, absolute underscore value, open parenthesis, close parenthesis, and that will execute the body of our function. Okay, so this is nice. This will do the same thing, but this is like the exact same thing as on the left, but just 2 lines longer. It does the same thing. So why are functions so useful? Well, functions get powerful when they are able to take some input to use in the routine. This is where functions really shine. And so how do we take input? We call the input parameters, and they go inside of the parentheses that are in the function definition. So before we had def space, then the func name, open close parenthesis, colon. Optionally, if you want to take some sort of input, you write the names of the input that you want to take, separated by commas if there's more than one. And then these are the variable names that you can use inside of your function body. So that means anywhere inside of this function body, you can refer to reference param1 and param2. And whatever values were given by the user are then stored in these variables inside of the body of the function, and you can use them as much as you want while you're in the body of the function. So let's take a look at our code. How do we make our code better here? Well, we had this def absolute value, but it was always using the number -12 because we wrote that in our code. So that's not as handy. What if, how can we make our function more powerful? Well, we can have our function take in a number and then, execute the body for that given number. So it'll work with more than just -12. So here I can show you. Before, the way we would have called this would be absolute value. Here on the right, we can have this be absolute value -12. So now this code works for an input -12, but we can pass in any value we want, not just -12. And we'll still go ahead and print the absolute value of whatever number was provided. Okay, one last power up. So functions can also optionally return some output. They don't have to just use the input for something and have some routine. They can also return back. And so this return value is going to be what the call to the function gets evaluated to. So how do we do this? We use the return keyword. So this is another one of the reserved keywords right here. It's only used inside of a function, and you can either return nothing if you want. You can have just return, or you do return space and then the thing that you want to return. And then, so if when this function is called, we reach this line in our function, then this value is what the function call will evaluate to. So let's take a look at an example. I had our code up here. I go into our replit and I paste this code in. So we're defining a new function called absolute value that takes in a number. Number is greater than or equal to 0. We print the number, otherwise we print the negative of the number. And we run our code here. Then 3 demo.py. Great. So this function prints 12. If I call this function again with the value 50, now it'll print 50, 12 and 50. I can call this again. No, negative 82. Let's do negative 82. So this always prints the absolute value of whatever number is given to it. But what if instead of just printing this out, we actually want to use this value for something else? This is where a return function, the return statement is really handy. So let's say that we want to print, let's say the distance, we want to write calculate the distance between two places. And maybe we'll take some input from the user for this. This will be a fun little problem. So one equals but how far is place 1 from you? This 2 equals float input. How far is place 2 from you? And let's just oops. I'm missing a parenthesis here. Let's just assume that they're on a straight line so we don't have to worry about tougher math here. This difference equals dist1 minus dist2. And if we print this out, the distance between 1 and 2 is we run our code here. It'll ask, how far is place 1 from you? Oh, let's say it's 10 miles from me. Place 2 is 15. That's a little bit awkward. Actually, I see. My head is covering. Let's run this again. So 10, and place 2 is 15 miles from me. So the distance from 1 to 2, between 1 and 2 is -5. That's weird. We don't talk about negative distances. So actually, what we probably want to do is print out the absolute value. But if I were to just call, absolute value here, and if I ran my code, think about what would happen right now. So I'm calling absolute value with the, in fact, let's make this even just very clear. Just 1 minus just 2. The absolute value of the distance is absolute value of this difference what's going to happen here? Well, when Python reaches, like executing this line, when the computer reaches this line, it'll call this function, which takes in a number, and then it prints out that number to the screen. And so if I run my code, say place 1 is 10, place 2 is 15, it'll print out 5.0 on its own line when it's executing or evaluating this function call. But then this function doesn't return anything, right? There's no return statement. And so absolute distance gets assigned nothing. It's just none. It's empty. So when we go and print out, there's nothing stored in this variable. It's just none. And so instead of printing in our function, we will want to return the number, or return the negative number. And so this way now, when this absolute value function gets called, this expression gets executed or evaluated, it will return a value back. So this will evaluate to either num or negative num, and that gets stored into the variable abs distance and gets printed to the screen in line 14. 10, 15. And here we end up printing the distance between 1 and 2 is 5.0. Now I want to show, let's summarize all the pieces that we've learned here of the full possible syntax. So we always have, this def keyword, always. And then after we have a space and the name of our function, and then open parentheses and close parentheses, followed by a colon. Inside of these parameters, inside of these parentheses, optionally we have parameters, which are the variables that will hold the inputs that the user gives to our function. And then in the body, we have, which is all indented, we have all of the lines that we want to execute that can use those parameters. And finally, optionally, we have a return statement, or multiple return statements. And these, as soon as execution of this body reaches one of these statements, we stop executing the rest of our function. And that is what the full function call evaluates to. There's one other place I thought I'd mention functions from. You might remember something very similar in math. And maybe you thought about it as kind of just, you learned y equals x squared. You might have learned about it as f of x, which were functions of a variable. So this is a parabola here. And a parabola is defined by f of x equals x squared. So on the x-axis, we have all of our possible inputs, 0, 1, 2, 3, negatives as well. And on the y-axis, we have the output of our function, which oftentimes we call y, but really is f of x. And so when our input to the function is 1, we call the function with f of 1, and the output is also 1. When our input is 2, we call our function f of 2, and the output we get back is 4. That's how we get to this point on our parabola. So you'll notice this is really quite similar to functions. X squared is the body of our function, so it's the routine that we're going to execute. X is the parameter because it's the variable name in the definition of the function. And then when we actually go to call our function, make the function call, in this case, 2 is the argument and 4 is the return value. And we figure out the return value by calculating what x squared is. So if we want to write this in code, our parabola function would take in x, so this is f of x, and it'll return back x times x, so x squared. And we can see if we were to run this code, f of 1, so parabola 1, would be equal to 1, and f of 2, parabola 2, would be equal to 4.